Earthquakes strike without notice, shaking the earth and destroying roads and bridges. To eliminate future catastrophes, highways must be built with deep foundations. One tool is doing it bigger and better. The Diesel Hammer.
Impact hammers are mean machines. They drive the foundation pile down to where we need them. These bridges could not be built without it.
25 feet tall and weighing more than a jumbo jet, the Diesel Hammer pounds road foundation piles into the earth without mercy.
In a word that's used a little too often these days, it's awesome. This is one of the largest diesel hammers that is produced.
Its 25-ton ram slams down at a rate of 25 blows per minute. When it strikes, the results are explosive.
The force on these hammers is incredible. You want to talk about foot-pounds. These puppies put out 450,000 foot-pounds of energy on that thing.
The soil surrounding each pile gives way. The hammer doesn't take long to push the piles 150 feet deep, the equivalent of driving a 15-story building straight into the ground. Today, the Diesel Hammer is in Oakland, California, the heart of earthquake country. The goal? Pound in stronger support piles for Interstate 880. Pile-driving foreman Ron Stanville knows the gravity of the task at hand. 200,000 drivers a day depend on the highway's safety.
If we don't do the foundation work underneath these bridges, they'll never hold up in an earthquake and thousands of people will die.
Ready to start pounding, Ron gives the go-ahead to the driving force behind the Diesel Hammer. Dennis Brand and his 250-ton link belt 718 crane.
I pretty much control it. I lift it up. The only thing I don't do is light it off.
Dennis moves the hammer over the first steel pile. The positioning must be perfect. If the hammer and the pile are not in line, the force of the blows could weaken the pile or drive it into the ground at an angle, compromising its load-bearing capabilities. Crew members direct Dennis from the ground as he guides the Diesel Hammer with the crane.
My flagman will tell me whether to boom up, boom down. They signal me in.
The hammer is set down on the pile. Dennis's reckoning is dead on. Now it's up to Ron to unleash the power.
These hammers are so strong and so powerful that there's nothing that we can't drive.
All its power and efficiency comes from one thing: continuous controlled explosion. As the hammer's ram drops diesel fuel, it's discharged onto the surface of the impact block. When the ram strikes the block, the fuel ignites, driving the pile into the ground. This first explosion is the catalyst for more violence. The hammer strike ignites fuel and compressed air in the engine cylinder. This second explosion drives the pile deeper. The blow is so powerful that the 25-ton ram is kicked back into its original position from the incredible force. Gravity pulls the ram back down, and the cycle repeats, pounding the pile deeper and deeper into the ground. To demonstrate the explosive strength of this chemical reaction, we packed an oven with a similar chemical known as tannerite. One bullet striking the oven ignites the chemical. Slowing the video down reveals that as 500,000 foot-pounds of dynamic energy is released, the oven is obliterated. The Diesel Hammer unleashes the same amount of power with every stroke. To withstand the Diesel Hammer's constant abuse, the road foundation piles are built tough.
These piles are 165 feet long, 12-foot diameter, 1.25 inches thick.
Abuse from the hammer is not the only thing these piles must withstand. Deeper soil has high load-bearing capability, but it's also extremely dense. This harder soil increases the strain on the piles, increasing the chances of misalignment. Halfway through the job, the guys are growing concerned. The blows from the hammer aren't yielding the desired results. If the piles become misaligned in the harder ground, the men will have to start over and waste a day. Luckily, the crew has a solution. This pile driving analyzer is a state-of-the-art monitoring system, commonly referred to as PDA.
So we're looking at monitoring the last part of the drive until we get the pile down to near its final position.
The crew must install sensors called accelerometers and strain transducers at 4 cardinal points around the pile: north, south, east, and west. The sensors measure the angle and energy of each blow and determine how the pile is holding up against the stress. All this data ensures that the piles are being driven in as efficiently and safely as possible.
We can see if the hammer is not properly seated on the pile, if it's giving blows that are not axially aligned with the pile, and if the steel is being overstressed as a result of that.
With the PDA installed, the hammer slams back down on the pile. The PDA transmits the crucial data wirelessly to the remote receiver. The data shows that the pile's alignment isn't perfect, but it is correctable.
It could have been aligned a little better. It was showing a harder blow on one side than the other.
The crew readjusts the hammer to correct the alignment and pounds the final pile home.
Feels good. I got 28 years in the union, Local 34. I'm proud to do the work.
With the piles driven in place, they're ready to be reinforced with concrete and steel rebar.
When you have a solid steel shell and a solid concrete core pile with a solid rebar cage in the middle of it, there's not much going to go wrong with that thing. So it can withstand some tremendous amounts of force.
Protecting highways against earthquakes is essential, and the Diesel Hammer answers the call.